Draw the trajectory of an object thrown with an initial velocity of 20 meter per second at an angle of 30 degree, 45 degree and 60 degree. Okay, so basically what we have to do is we have to draw this in the same diagram. So we need to draw this, provided this is, what is this? 20. Okay, for us it's too small over here. Point is we need to draw something like this for say 45 and for the same initial velocity, but for 30 degree and 60 degree. So basically what do we need for this? Yes, one thing is we need a graph. Then what else? To compare within themselves, we need the range and the height. Okay. So what we have here is, so we have, how do I start off with? Let's figure out the maximum height. H max is what we'll figure out for each case. Say I don't remember the formula. What can we do? So we know that we have an object thrown at a particular angle, and the angle with the horizontal is say 30 degree, 45 degree and so on and so forth. This is 20 meter per second, and when resolved, this would be 20 sine of the angle, right? Because we have three different cases. So H max is given by, so at the peak, so since we're looking at the highest point, at the peak the velocity is 0, v square is equal to u square minus 2 into g into h max. So this would be the y component. This is what I used while deriving. So h max is equal to v naught, this would be 20 sine of theta the whole square divided by 2 into g. Okay, so one step away I have the formula, right? So now we have cases for theta is equal to 30 degree. My h max will be 20 into sine 30 is 1 by 2. So 1 by 2 into 1 by 20. I'm taking g as 20 by the way, sorry 10. So this is basically half a meter. So this is case 1. Then we have case theta is equal to 45 degree. So h max is how much, guys? This will be, 20 square, my bad. All of this is wrong. So this would be 400 into 1 by 4 into 1 by 20. So 100, this will be 5 meters. Then this would be again 20, this is 400 into sine 45 is 1 by root 2. So square of that is 2 into 1 by 20. So this is 40, this is 10 meters. Then we have case when we have theta is equal to 60 degree. This will be the highest. So for 60 degree, it would be 400 into root 3 by 2 square is 3 by 4 into 1 by 20. So 1s are 20s are 5s are 15 meters. Perfect. Okay, then what else we have? So this was your say height. Then we have the next thing. What do we need to draw? Roughly to draw, not exactly. Roughly it would be the range. the horizontal distance basically. So what is the formula? Honestly, I don't remember the formula. But I know it is to do with, R is to do with V naught X into the total time of journey. And to figure out total time of journey, what can I use? I can use this itself. So I'm trying to derive, by the way. So V is equal to U plus AT. So this is the time for half the journey, remember? So this is T by 2. Okay, so again, I'm trying to derive. This is not part of the answer per se. Say I don't remember, and I'm able to do this. As simple as that. I got T, time of flight. How did I get this? At the peak, at the top, we have things to be 0. The final velocity is 0. Initial velocity is this. And acceleration due to gravity is this. And time of flight. So because I know the time of flight is dependent on the y component, I just dealt with the same thing again. Whatever I did over here, same thing I did. I resolved the vector, so on and so forth. And I got this. Oh, sorry. This is my bad. V naught y is nothing but this. So this will be V naught sine theta. Okay, so we have R is equal to V naught X, that will be V naught cos theta into 2 V naught sine theta by G, a bit of solving, and V naught square sine 2 theta by G. Again, I'm deriving in front of you guys. So you can directly write the formula, or if you don't remember, actually initially derive every time, till you remember the formula. So case theta is equal to 30 degree. We'll start with that. So R for 30 degree will be, so V naught square is 400 into sine of 60 divided by 10. So sine 60 is root 3 by 2. So 20 root 3 meters. Root 3 by 2, 20, 200. Yeah, perfect. So next is we're looking at case of 45 degree. So R 45 degree. Oh wait, sorry, this is 60 degree. My bad. I wrote 30, I wrote here 60. So 400 into 90 is 1 divided by 10. This is 40 meters. And case of theta is equal to 30 degree. This is same as 60 degree, right? This is 20 root of 3. That's it. Okay, so I hope you guys remember this, because sine 2 theta, because of this, we have sine of 2 into 30 degree is same as sine of 2 into 60 degree. Because they're complementary of each other. So they end up being this. Oh, sorry, this is sine of 120 degree. My bad. Sine 120 degree, sine 30 degree, and this value will not be this. Oh, I don't know why am I making such mistakes. Not concentrating, I guess. Sine 60 is cos of 30, which is, okay, same thing actually. Yeah, you get the same answer. Okay, so now what we have to do is consider this, draw a rough diagram, right? Have some scale and all of that, and you will end up with the answer. Okay, I'm thinking of the scale actually. What to take? So our rough diagram, and we are done with the answer. So the values are 40 meters is the highest, right? 45 degree. And the peak is 15. 40 degree and 15. So this can be 1, 2, 3, 4, 5. Okay, what can I do? 40 is say 10, 10, 10, and 10. I still have more range, but anyways, let's go with this. This is 40 meters. Then this is 5, 5, 5, 10, 15. Or I can go a bit 5, 10, 15. Okay, can go with that. So this is where the object is thrown. So 45 degree, let's have a look. 45 degree is 10 meters high and 40 meters away. So 10 meters high would be here for me and 40 meters away. So this would be our trajectory. Again, a rough diagram is what they want. It's a good practice actually. It's a good practice question. Then we can go with 30 degree. This color is for me 45 degree related. Then we have 30 degree, 20 root 3. 20 root 3 is approximately, guys. Actually, I was calculating that itself. 34. So 34 is, this is 40, this is 30, 34 would be, this is 35, somewhere over here. Okay, let me go with 30 degree. So 30 degree, the height will be less, 5 meters. So 5 is this height. That's the maximum. Oh, not that. You can see it's so natural, as in the curve comes out to be so. And then we have, other one is the highest when it reaches the, among these three, this is the highest, reaching 15 meters. So here, but reaching the same point as 30. Okay, guys. So this is approximately 34 meters. This is 5 meters, 10 meters, 15 meters. That's it. Okay. And yeah, you can have a look. So one thing that I want you guys to take out of, take from this set of discussion is that I derived everything. I don't remember. You have to end of it, but consider that, I mean, as of now, you will not be remembering this. So derive every time. Please take my suggestion. Derive every time. Write. Give it a good try. Once it becomes very familiar, then memorize. Till then, don't memorize.